Hello there, folks. Hey, this is Joe Wazoo here. I'm just doing a first video on a new product from Banner Engineering called the SnapSignal converters, and I've got a new one here that does a lot of things. I just thought I'd show a first video on how I'm using it just out of default, out of the box. So SnapSignal is where it's at on Banner's Engineering website. I'm going to go down here and I'll find this in the converters. So I'm going to click the Learn More here. And then on the converters, I'm going to click on the S15C converters, this guy right here. So I'll click here, and that brings you to an intro video and so forth. But if I go down a little further here, it'll show you all the different models that are available. And I'll be doing some videos on a few of these other ones. But the one I have that is very interesting is this model right here, the S15C-B22-MQ. It's got a discrete input output on it, and it does a bunch of different things. List price on this is $92. So if I click here, it'll take me to the specific page on that item. And there's that guy right there. And then more importantly, if I expand the downloads category, and there's a technical document here on this unit. So if I click on that, it'll open up the document and so forth. And so what I did is I just went ahead and looked this document over. Let me make this a little bigger so you guys can see. And I went ahead and took a red line HMI to become a Modbus 45 master to talk to this thing. And I've created a bunch of tags already in here. So let me go to the Crimson program. So here's the Crimson program I'm going to be playing with. I'm going to be using communications to talk to this thing. It's a Modbus 45, so on one of the RS45 ports on whatever Redline product you might have, I'm going to choose the Universal Master here for Modbus. RTU is the type. The Banner products do a baud rate of 19200, 8 and 1 and none. 2-wire RS45. If I click on the first item here, that's going to be drop number 1. That is default out of the shelf or out of the factory set to that. The rest of these are just some other numbers I'm playing with to tinker with, but I didn't have to do any other changes in here. That's all I'm doing here, stock settings. And then over here in data tags, I went ahead and created tags for the pin 4 or pin 2. So if you look here, I've got this active state, for instance, it's mapped to 40,001. If I go back to the website here, oh, maybe I got to do it this way. We're going to go this way. 40,001 is this one right here. If I go back to the Crimson, why is that tool doing that? I don't know. But if I go to the counter, you'll see it's number 3. Next was number 4. I went ahead and created a long here in Crimson to do that, and so forth. So I've got all these tags set up in here. And what I'm doing here is I'm also using a TURCK product to run ARGEE code to simulate a discrete signal. So I have on this product, I've got it wired. Can I clip? I don't know why I can't seem to Alt-Tab here. I have a discrete input coming from an FEN20, one of TURCK's IO blocks, that I have wired into on here, input number 1, pin number 4 right here. I've got it here, and that's my input signal. So let me go to the web browser of my 2 items here. Give me a second here, team. So this is the HMI screen here, and then I'm also using another screen to talk to the FEN20 here. So let me go ahead and, all right, so if we go, that's interesting, all right. Okay, so we go there. Why did I do that? Okay, well, whatever. All right, so if we go here, go to my pin 4 flow chart. This is what the document is. Everything is set up here for disabled right now, or not disabled, but default. So I've got all this set up as default in here. And if I go to the pin 4 IO data, you can see right now that pin 4 is wired to the output of the FEN20. So if I set this to maybe, let's do every 3 seconds here. I'm going to show you the ARGEE code I'm running here. Maybe I won't. It's right here. So this is the ARGEE code that's running every 3 seconds. 1.5 seconds it's on, the other 1.5 seconds it's off. Thanks to Ron helping me write that extensive code, pretty sweet. But back here at the HMI, there's that there, and so forth. So you can see here the input signal goes on and off right here, as you can see. If I make this 10 seconds, we'll set the expiration window here. So in this case, you're going to see the signal is going to go on here in a second. There, it's on now. It'll stay on for 5 seconds, and then the other 5 seconds it'll be off. So you're also going to see down here that I got this tag called time on signal. I'm basically taking one of the other tags, duration, right here, and converting that to a time. So that's where the time's coming from. If I change the cycle time to 5 seconds, or 5,000 milliseconds here, you'll see this will actually settle down to 2.5. And yep, there you go. And that's what it's doing. It's also counting. So if you look right here, team, there's a counter high and counter low. And since we've been kind of doing the video playing with different times, it's counted up to 83 here as we start. If I take this to once a second on and off here, so now the signal is going on and off much quicker, and you'll see the count rising edge goes quicker. If I take the signal to say 500 milliseconds, you'll start to see that shows up faster. You can see here that at 500 milliseconds, it's saying events per minute would be 120. So that's probably correct if you do the math. That there. If I go ahead and change this even further, say I take this down to maybe, if I just tab here to maybe 50 milliseconds, let's see what we get here. All right, so now I'm pulsing very quickly on and off, and you can see the counts change accordingly here. And of course, the cycle time is run right here. In this case, running at 50 milliseconds, events per minute. There's the number there. If I take this even further, it's really interesting. I can go all the way down to about 5 milliseconds here with the ARGEE code. Right about there. And you can see that this number is dramatically, because I'm pulsing so fast on the ARGEE, I actually also have an LED light on the output. It's pretty much constantly on right now. And you can see those numbers change accordingly. So this is, everything's in the default setting right now. Out of the box, I literally have it plugged in, input going to pin 4, and it's a high-speed counter. Really, that's what it is right now. It's acting as a high-speed counter. That pretty cool little product. I'm going to do some other videos on the other modes, because there's about 8 different modes for this. So I'll get to some others, but this is out of the box. This is how this thing operates right now before I've done any changes. Anyway, watch for another video shortly. Thanks.